Hello everyone and welcome to tutorial number 53 in a series of video tutorials for Java programming. Don't forget to click on the subscribe button and click on the bell icon as well to stay up to date with every tutorial I upload on my channel. So in the last tutorial I discussed about the concept of generic classes, generic interfaces and generic methods in detail. So if you have not understood or if you don't know the concept of generics, then you can go and watch the last tutorial. So in this tutorial we are going to continue from where I left off in the last tutorial. So we are going to talk about generic constructors. Okay, so as I told you in the previous tutorial itself that this is the way by which we are going to create a generic constructor. Okay, so first of all we are writing public or private. This is not mandatory. Okay, the success specifier is not mandatory. It is up to you whether you want to mention it or not. Okay. So this is generally used for this OOPS means object oriented programming. So this is generally used for abstraction and encapsulation purposes. So you may use it if you want, you may skip it if you want. Okay, it is completely up to you. Then after this we use this type parameter. Okay, open the angular bracket, write T, close it. Then after that this is the name of the class. Obviously, as we already know that constructors, they have the same name as the class name, and this is a parameterized constructor, so this is going to accept object of type T, which is the type parameter. Okay, so in the last tutorial I just showed you how to create this this particular constructor. So first of all, let us to understand how this generic constructor is going to work, let us see what exactly is bounded type. Okay, so right now, as I said in the previous tutorial itself, what is bounded? Okay, what is bounded type exactly? Okay, so bounded type means right now if I want to call this particular constructor, okay, there is no bounded type in this particular constructor. Right now in this particular I can call this particular constructor by specifying 25. I can write let us say I can write YouTube. Okay, I can provide a character, I can provide anything whatsoever I can provide. I can write let us say character, then I am providing let us say a boolean value. Okay, so it is this particular constructor, it is accepting all types of values. Okay, but what if I want this particular constructor to accept only numbers? I don't want it to accept the string, I don't want it to accept boolean, I don't want it to accept this character. So what exactly is the way to do it? The way to do it is by using the concept of bounded types. Okay, so if I want to use bounded types, then what I'm going to do, I'm going to write extends. Okay, now you should remember that I want this particular constructor to accept only numbers, so I should write number here. Okay, and as soon as I type this number, you can see that the code which I've written in the main method, it is already starting to give an error because this thing is not allowed. Now right now this particular constructor, it is going to accept only numbers. Okay, it is not going to accept anything apart from numbers. So it can accept let us say a floating value, let us say 3.14f. it is going to accept that. Okay, it can accept a long value, let us say I write 1000L. It can accept a long value, it can accept a double value as well. Okay, let us say 24D. Okay, so D means this is a double, this is long, this is float, and this is an integer. So this particular constructor right now, it is accepting only numbers. Okay, I already showed you that if I write let us say a character here, it is going to give an error, it is not going to accept it. Okay, so it is giving an error here, it is saying no instances of type. Okay, character is not conforming to number, because this number, it is a upper bound means this particular constructor, it can accept only numbers. Okay, or it is going to accept only like for example here I am saying integer, that class integer, it is a subclass of number, and this float is a subclass of number class. Long, it is a subclass of number class. Similarly, double, it is a subclass of number class. Okay, so that is what the upper bound is all about. Okay, there is a concept of lower bound as well, but right now I am going to talk I am talking about the concept of generic constructors. Okay, so I just wanted to show you, I just wanted to explain how the bounded types are working. Okay, so right now we are just going to talk only about upper bound. Later on we'll see how the lower bound is going to work. So then after this, let us see how the generic constructor is going to work. Alright, so right now what I'm going to do here, I'm going to declare, let us say I'm going to declare a variable here, private, let us say double d. Okay, then here what I'm going to do, since this particular t, it is extending from number, it is this t, it is going to have all the methods which are going to get defined in the number class. Okay, so let us do that. So this d, I'm going to write d is equals to t dot double value. Okay, so right now if you remove this particular statement extends number, then this particular double value, it is not going to be valid. Okay, since t is extending from number, okay, that means the t, it is a subclass of number class. So because of that, it is going to extend all the functions which are defined in the number class, and this particular thing becomes valid. Okay, then after that I'm going to write system.out.println, I'm going to write d. Okay, so right now if I press the run button, let us see what the output comes as. Okay, so let us wait for the program to execute. Okay, so this is one of the way of using a generic constructor. Okay, we can use bounded types. It is not mandatory to use bounded types, but for this example I am using bounded types. Okay, so because I wanted to explain the concept of bounded types as well as generic constructors, okay, both in the same example. So right now you can see that 25, it is showing us 25.0. okay, 3.14, it is showing us 3.14. then 1000 L, it is showing us 1000.0. 24 is showing us 24.0 itself. Okay, so because it is printing the double value, in much the same manner, if I write only the int value, that is also going to be perfectly valid. Okay, so let us print out the int value. Int value means it is going to print 25, 3, 1024. Okay, but still it is printing out that decimal value. Okay, it is even then also it is printing out the decimal value. Okay, but here you can see that the 3.14 has been it has been shortened to truncated to 3.0 here. Okay, so that is how this generic constructor is going to work. Obviously you can explore more from your side. There are more usages of this generic constructors. Okay, and there is a concept of lower bound as well in this bounded types. Okay, so instead of extends number, you can write super. Like for example, you can write super object or something like that. I think super object, I don't think you can write super object here. Okay, but there is a concept of lower bound as well. Okay, so we will be looking at the lower bound when we use we will be using the lower bound here mostly. Okay, so now the thing is, this is the okay, now the thing is I'm going to talk about the wildcard arguments. Okay, so let us talk about the wildcard arguments. Okay, so now the thing here is, okay, here I have defined a function called as same average. Okay, you all know that what average is. Okay, average is obviously the sum of all numbers divided by the number of numbers. Okay, like let us assume there are 20 students in a class, and each and every the total sum of all the students I mean the marks of all the students is, let us say, 680. Okay, so 680 divided by 20, the average comes out to be 34. Okay, so that is exactly what the concept of average is. The sum of total of all the students in a class divided by the number of students in the class. That is what average is, right? So it was not necessary to explain the concept here, but you would have probably know it already by now. So now the thing is, I am checking whether I am comparing objects of two generic let us say I am writing t here. First of all, I want to show what happens if you don't use wildcard arguments. First of all, I want to show what happens if you don't use wildcard arguments. Okay, then after this I'm going to show you what happens if you would use wildcard argument. Right now, before I change this to T, if you have noticed it carefully, there was a question mark here. That question mark means it is a wildcard argument. Okay, so that I was testing it out earlier from my side, before I was preparing for this particular tutorial. So I wrote this two methods in that for this purpose only. Okay, so this particular method is going to return average of 0 only. Okay, this is just an example. It is not something like it is going to run a program or something. It is just an example. So this is just for demonstration purposes, so that's why I'm returning 0 here. Obviously, if you're writing a proper program from your side, then you should not return 0 here. Okay, but this is just to explain the concept of wildcard arguments. So now this particular method, it is accepting a parameter of generic type. Okay, and it is comparing if average is equals to generic dot average. It is checking whether the this average, okay, this dot average. Obviously you know that you can write this dot average here. Okay, you can definitely write this dot average here. It is not going to give any errors whatsoever. So if this dot average it is equals to generic dot average, then it is going to return true. It is comparing whether the values of both of them are the same or not. Okay, if it is the same, it is going to return true, otherwise it is going to return false. Okay, right now you will say that it is going to return true only. Obviously it is going to return true. I know it very well, because it is calling the same average function. It is returning 0 only. Okay, but that is not the point. That is not the point. I am talking about the concept of wildcard arguments here. Okay, I am not talking about the concept of averages here. I am not talking about that it is going to always return true. Okay, so right now we have this particular function. Okay, now I want to call this particular function over here. Okay, so let us call this function here. Okay, so this particular generic class, it has parameterized constructor. It does not have any default constructor. Please keep that in mind. It does not have any default constructor, because I already told you when I explained the concept of constructors, if you define a constructor yourself, okay, then the compiler, it is going to erase this version of default constructor. Okay, so there is no default constructor in this particular class. Please keep that in mind. Okay, I already mentioned that. I am once again repeating it here. Then after this, if I try to create object of this generic class, let us say I'm writing double here. Okay, then gen d, it is equals to new generic. Okay, so right now you can see that it is giving an error. Okay, the reason why it is giving an error is because this particular this particular class, it does not have a default constructor. I told you a lot of times, okay, when I explain the concept of constructor also, and once again I'm showing it here. Okay, so please understand this concept properly. So after this I'm going to write, let us say 24d. Okay, so I'm giving the value of 24 to this particular constructor. Okay, then after this I'm creating another object, okay, with a different type parameter. Let us say I'm writing integer. Okay, then I'm writing gen I, it is equals to new generic. Let us say I'm writing let us say 100 or something. Then after this what I'm going to do, okay, after this what I'm going to do is I'm going to compare the object of double with integer, and it is going to give an error. Okay, so let us see what happens. Gen d dot same average, I'm going to call this particular function. I'm going to call this particular same average. Okay, then I'm going to pass gen I as a parameter here, and as soon as I pass the parameter here, you can see that it is giving an error. Okay, what error it is giving? Required type is generic double. Okay, but I am providing generic integer. Okay, the reason why it is providing an error is because I am not using the concept of wildcard arguments here. Okay, if I use the concept of wildcard arguments here, then this concept will get, this particular error will get resolved automatically. So how am I going to resolve this error? Okay, resolving this error, even though it seems very complicated, it is actually very simple. All you need to do is, do you remember just a few moments ago, there was a question mark present over here. Okay, I changed it to T because I wanted to show, what happens if you don't use wildcard arguments. So if I change this T back to question mark, then if I return here, you can see that error has gone away. There is no error over here. Okay, so that is why we are going to use a wildcard argument. Okay, in much the same manner, if I want to compare gen I with gen D, okay, and if I don't use the concept of wildcard arguments, okay, if I change this back to T, let us say, okay, then it is going to give an error. Okay, so the reason why it is giving an error is because what the compiler is expecting is in the left hand side you have double, so in the right hand side also you need to have double. Okay, that is the case in the line number 10. Okay, that is why it is giving an error here. Here in the 11th line, what is happening, it is in the left hand side we have integer, we are passing the object of integer, generic integer, gen I. Okay, and in the right hand side also the compiler is expecting the object of generic integer only. Okay, all of a sudden you are passing object of generic double, so the compiler is getting confused and it is giving an error. Okay, but this error can be resolved simply by changing this to question mark. Okay, so then after this this was the concept of wildcard arguments. Okay, if you are comparing object of completely, let's say we this is a object of the same class but it is having different type parameter, right? I am comparing the object of the same generic class. One is with type parameter double and another is with type parameter integer. Okay, if it is of the same type parameter, then it is not even going to give an error. Let me show you that as well. Okay, I am going to change this back to T. Okay, and what I am going to do, I am going to write generic integer here. Okay, I am going to write here gen I2 equals to new generic 200, let us say, and I am comparing gen I dot same average gen I2. Now what am I doing here? I am comparing the object with the same type parameter. I am comparing two objects of the same generic class with the same type parameter. Okay, and here I am not even using the wildcard argument, and what is happening, it is not giving any error. Okay, so you need to understand the concept here. Okay, if as soon as I change this back to D, it is going to give an error obviously, because I am using a different type parameter. Okay, gen I, it is of it is an object which was created with type parameter of integer, and gen D is the object of the same generic class with a different type parameter. It is of type parameter double, so it is not going to work. Obviously it is not going to work. Okay, so that is how this particular the concept is going to work. Okay, so if you want to compare two different objects of a generic class with different type parameters, then you need to use wildcard arguments. Otherwise the compiler, it is going to complain that you have an error in the code. Okay, bounded wildcard is very easy. Bounded wildcard, let us say I am writing T extends number here. Okay, so right now what is happening here, I can provide even let us say I can even write string here. Okay, obviously I can definitely write string here, and it is not going to give any errors here, because the way this concept is going to work, it is not going to give any error here. Okay, but I want this particular function to accept only numbers, because obviously average means it has to accept only numbers. Okay, so that is how the concept is going to work. So I'm writing T extends number. So as soon as I write, wait a minute, unexpected bound. Okay, T extends number. Okay, fine, I need to write it here, T extends number. Okay, as soon as I write T extends number here, it is going to give an error here. It is not going to accept string. Okay, I think yeah, that is no, wait a minute, we should not write T here, we should write question mark here. We should write question mark extends number, because that is the concept of wildcard, that is the concept of bounded wildcards, right? Okay, so I am going to return back here. I am going to remove the remove extends number from here. Okay, then what is going to happen is, since I am using the concept of bounded wildcards, I cannot pass string, I cannot pass gen D as the argument, I cannot pass this as an argument to the function. Like for example, I'm writing gen I dot same average gen d. This is not going to work. This is definitely going to throw an error. Why it is going to throw an error? Because it is going to this particular function string, it is not extending from number, right? That is why it is throwing an error. However, if I write gen I2, it is going to work fine. In much the same manner, I can write the opposite of this also. I can write gen I2 same average gen I. Okay, so that is the concept of bounded wildcards. Okay, bounded wildcard means you need to write a question mark, then after that extends number. Okay, so that is the concept of bounded wildcards. So in much the same manner, let us say you can even write super integer here, I think. Okay, so that is the concept of a lower bound. Okay, if I write question mark super integer, I can pass this integer becomes the lower bound. Okay, this is a concept of lower bound in bounded wildcards. Okay, bounded wildcard arguments. Okay, so right now what I'm going to do here, let me try to create object of double here. Let us see what happens. Gen I3 equals to new generic, let us say 28D. Okay, then after that gen I2 dot same average gen I3. Obviously it is going to throw an error. Okay, why it is throwing the error is because the lower bound has to be integer, and it can only the super classes, it is going to accept only the super classes of integer. Okay, so double, you should remember that even though double is a subclass of number, it is not a super class of integer, so you can accept only integer right now. Okay, so that is the thing which you need to keep in mind. And if I want to use lower bound here, can I use lower bound here? No, I cannot use lower bound here. Okay, we will see this particular concept of lower bounds in a later tutorial. Okay, now there is another concept of raw types, okay, which we have not discussed. Even though we have not discussed this particular concept in the PPT, okay, I want to discuss this particular concept here. Okay, now we know that this particular class, it is a generic in nature. We already know that. There is no doubt that this class is generic in nature, but there is a raw type of this generic class. Okay, so what do we mean by that? Like let us say I am writing generic gen equals to new generic, and after this I am writing, let us say 35. Then if I hover over this, it is saying raw user parameterized class generic. Raw user parameterized class generic. Okay. Now actually there is a problem by using this raw type. Okay, the problem with using this raw type is that it can create the problem with it can create some problems like type compatibility and all those things. Okay, so like for example, let me try to write set t or get t. Let me see what happens. Like right now I'm writing gn dot set t. Okay, then if I write Ahmed here, then I'm writing system dot out dot println gn dot get t. Then what is going to happen? What is the output going to be? Okay, so let us wait for the output. Output is Ahmed. Okay, so actually it is working fine here, because here it is setting t, and yeah, here it is setting t. Okay, this is obviously this is a raw type, obviously. Okay, but the problem with using this particular code is that sometimes it can create let us say type incompatibility. Like, okay, for example, let us write integer here. Okay, if I write integer here, then you can see right here that I cannot write Ahmed here. Okay, because Ahmed is of a type string. Okay, the data type of Ahmed is string, and the data type of 35 is integer. Okay, so it is not even accepting. You can see it right here. It is not even accepting. It is giving an error right away. Okay, you are trying to provide a string to an integer, which is not allowed in Java, right? So that is why we should not say, you are not supposed to use raw types. Okay, we can definitely use them in certain cases. Okay, in circumstances we can use raw types. Okay, but as soon as I remove this particular generic integer, okay, then it is going to accept the Ahmed also. It is going to accept Ahmed as well. Okay, so if I write, this is a kind of raw use. Okay, if I can use this particular class as a raw type, then it accepts even Ahmed also. Okay, even the string values also getting accepted in integer. Okay, so that is a kind of a problem actually. Okay, so let us say I'm writing t extends number here. Let us say, okay, I'm writing t extends number here, and okay, let us leave it here for now. Okay, let us leave it here for now. At least for now it is fine, I think. Okay, so because we are running out of time as well. Okay, so we will look into this raw type into more detail in the next tutorial. So in this tutorial we talked about the concept of generic constructor, bounded types. Okay, I will talk about the lower bound later on. Okay, I need to look into it, and we'll be looking into it in a future tutorial. Then we already talked about the concept of wildcard arguments, why we use them. Okay, I also told you what happens if we don't use them. We saw the concept of bounded wildcards. Okay, and I also introduced the concept of raw types. So I think what I'm going to do in the next tutorial is I'm going to take you I'm going to take you back to the PPT, and I'm going to use the PPT for let us say 3 or 4 more tutorials after this. Then after that we will return back to the IDE, and then we will carry on with the tutorial series. So I think that's all I'm going to talk about in this particular tutorial. If you have any kind of doubt or any kind of questions, then don't forget to post in the comment section below. And if you liked this particular tutorial, then don't forget to like, share and subscribe. And yeah, I will see you in the next tutorial. Till then, bye.